Okay, let's give you guys some more practice. So establish if this integral converges or if it diverges. So press pause and have a go. Okay, so to do this, we should be comparing this to 1 over the square root of x. If you look at this, if you look at the denominator here, if you look at the denominator, if we just look at this bit, if we just look at this bit here and discard this this negative 1, meaning looking at this, if I don't take away anything here, then the denominator here will be bigger than the denominator here. But then if the denominator here is bigger, then that makes the overall thing here smaller. So what we're trying to say is that this thing here must be smaller or equal to this thing here. So the comparison that we should be making would be this. Looking at this here, looking at the two denominators, if we don't take away anything, then this denominator here will be bigger than this denominator here because we're not taking anything away. Well, if this denominator here is bigger, then the overall thing here will be smaller. So that means this thing here must be smaller than this thing here. Well, this thing here is smaller than this thing here. So now taking the integral from 3, so this is 1 from 3 to infinity, 3 to infinity. This thing here actually diverged. So you should know this by now. This thing here would diverge. Well, if this thing here being smaller than this thing here, if the smaller thing diverge, then this thing here has no choice but to also it will also diverge because this thing here is always bigger or equal to this thing here. If the smaller thing diverged, then the bigger thing will have no choice but to also diverge. So overall, this thing here will diverge. I hope you understand that. Next question here. So establish if this thing will converge or if it will diverge from 0 to 5. So press pause and have a go. Okay, so to do this, we should be comparing it to the cube root. So if you look at the denominator, if we don't add anything, then this thing here will be smaller. This denominator here will be smaller. So if the denominator here is smaller than the denominator here, then the overall thing here has to be bigger or equal to this thing here. So we can say that this thing here must be bigger or equal to this thing here. And then if you look at square root, well, if you look at 1 over x to the power of 1 looks like this. From 1 to 0, from 0 to 1, this area here will diverge. But then so this is for the case of x to the power of 1. For anything less, the graph will look something like this. Now this thing here will converge, and we've done this many times. This thing here will converge. But by the way, even though we're not really doing it from 0 to 1, we're doing it from 0 to 5. You can always break this up. So this is 5 here. Just say let's do it from 1 to 5. This is going to be a definite area, and then you can just analyze this bit here. The point here is that this thing here will converge, and you should know this by now because we've done this many times. So this area here will converge. This area here will converge. Well, if this is bigger or equal to this thing here, if this thing converges, then this will have no choice but also to converge. So in this case, this thing here will converge. Okay.